Hello everyone and welcome back to another episode of Math with Dr. War. Today's lesson is for my college students and we're going to be simplifying complex fractions. With complex fractions, basically you have a fraction dividing another fraction. And I did a video when I was multiplying and dividing fractions and I included a complex fraction there. And when I included complex fractions, I said an easy way to think about it is like apple pie. So if you have to bake an apple pie or make an apple pie, you usually have your crust first, then you have your apples, then there's my division sign. You have cinnamon. So some people like to sprinkle cinnamon at the bottom. Under that, you have the crust. So basically, with your apple pie, you have crust, apple, cinnamon, and then crust again. So to solve these, basically, your numerator will be crust times crust. So you have crust multiplied by crust. And then your denominator would be your apples times your cinnamon. Excuse my handwriting. So here I have 5 over 12 c to the third d divided by 15 over 16 c d squared. So the 5 here is my crust and the 16 c d squared is also my crust. So those two will multiply each other. So 5 and the 16 cd squared will multiply each other, which means the 12c to the third d and the 15, which is the apples and the cinnamon, will multiply each other and be in the denominator. So I'm going to have 15 and you're timesing that by 12c to the third d. Now I'm going to do this without a calculator. So if you have a calculator, in these classes, students tend to use a calculator. I'm not going to use a calculator today. So I'm just going to expand this. So 5 is just 5 times 1, which is 5, times 16 is 4 times 4. And then I have times c times d squared. And then 15 is 5 times 3. And 12 is 3 times 4. And then I have c to the third and d. I'm going to begin canceling. So these 5's cancel each other out. This 4 cancels itself out. So in the numerator for my integer, I'm just left with a 4. And in the denominator, I'm left with 3 times 3 is 9. Now I'm going to go to my variables. I have c and I have c to the third. They're dividing. And remember, when you're dividing, you keep your base and you subtract your exponents. Now I notice that the majority of my c's are in the denominator, so that's where my answer will be, and I'm just going to subtract 3 minus 1, which gives me 2. Again, I'm dividing, so I'm going to keep my base. Now I notice the majority of my d's are in the numerator, so that's where it's going to be, and 2 minus 1 is 1, so that's just d to the first. And there's your answer, 4d over 9c squared. Now this one's a little bit more complex because we have addition and subtraction. So our first step is to actually find the LCD. So I'm going to come over here. So I have 2 over y squared plus 1 over y. I'm dividing by 4 over y squared minus 1 over y. LCD here, because they're all variables, will be just a variable with the greatest exponent. So y squared. And over here, y squared. Now this already has a y squared, so we're going to keep the numerator 2. Over here, this is a y. I need to make it a y squared, so I would have to multiply by y here and here. 1 times y is y. Down here, we have the same y squared and y, so guess what? Your LCD is y squared. Again, this is already y squared, so we don't need to change it. We're going to keep the 4. However, this is just y, and I need to make it y squared, so you're going to have to multiply by y, and 1 times y is y. Now remember, when you're adding and subtracting fractions, when the denominators are the same, you keep the denominator. So I'm going to keep the y squared, and I'm going to combine my numerator, which will just make a number sentence. So this will be just 2 plus y over here, my denominators are the same, which is y squared, and I'm going to combine. So that would just be 4 minus y. Here's your crust and there's your crust. This would multiply each other. So this would be y squared. And then that's 2 plus y. And then the middle section, which is the apples and the cinnamons, will multiply each other. So that would be y squared. And then you have 4 minus y. And guess what happens? These two eliminate each other. So your answer is 2 plus y over 4 minus y. So we had to do addition and subtraction of rational expressions to get it into the complex fractions, such as this. And then we did our little apple pie. So over here, we have to find the LCD. Okay, so I notice I have x here and x. They're both to the same exponent, so we're going to keep it. And then I have y squared and y. We want the variable with the greatest exponent, so we're going to take the y squared. LCD is xy squared. Okay, when I look at this, it's xy squared, so we just need to keep the 4. Over here, I just have xy, but we need xy squared. So we're multiplying by y here and here. So this will be 3y. Over here, let's find our LCD. So I see x squared. I don't see an x over here, but we're going to need it. And then I see y here and y squared here. Remember, y is common to all two, so we're going to take the one with the greatest. So this is y squared. So your LCD is x squared, y squared. So this has x squared, this has x squared, this has a y squared, and that has a y. We need it to look like our LCD. So you're multiplying by y here and here. So this is 6y. Over here has a y squared, but we need x squared, y squared. So we don't need a y, but we need that x squared. So you're going to times by x squared, x squared. So this is 2x squared. Our denominators are the same. So it was going to be just xy squared. We're going to combine the numerator, which is just going to be a number sentence, 4 plus 3y, over, okay, here, these are the same. So you have your x squared, y squared, and let's do our number sentence. This would be 6y minus 2x squared. Remember our apple pie, so crust and crust. I just do the crust. Once I get the crust, I know who's multiplying. So this will be 4 plus 3y times your x squared, y squared, over, and then the middle portion, xy squared over here. And then this would be 6y minus 2x squared. And let's start simplifying. So x squared divided by x will leave me with an x in my numerator. And then the y squared and the y squared, they cancel each other out. Now at the top, I still have my 4 plus 3y. 6y minus the 2x squared. You can actually factor out the 2, so let's factor out the 2. So if I factor out the 2, I'm going to be left with 3y minus x squared. So your answer, if we write it nicely, is going to be x times 4 plus 3y over 2, and then that's 3y minus x squared. Let's try this one. I'm going to make this a fraction. I'm going to put it over 1. So my LCD is just going to be 2x. This is already 2x, so that 5 is going to stay. However, here I need to make the 1 a 2x, so I'm timesing by 2x, top and bottom. So this will be 12x. Over here, 6x and 1, so I know my LCD is 6x and 6x. This is already 6x, so I'm going to keep the 5. However, here, to change this 1 to a 6x, I would have to times by 6x, so that will be 12x. The denominators are the same, so that will be your 2x. Make your number sentence, 12x minus 5, over, denominators are the same, 6x. Okay, make your number sentence, which would be 5 minus 12x. Crust and crust. So what do we have? We have 6x times the 12x minus 5. And then the apples and the cinnamon would be 2x times the 5 minus 12x. When I look here, notice these two are alike, but they're just reversed. Like this is 12x, a positive 12x, and a negative 5. This is a positive 5, and this is a negative 12x. We can actually make this look like this by taking out the negative. This would be 6x with 12x minus 5. and I'm going to factor out the negative. I'm going to put it here, and then you still have your 2x there, but then this will become this, which is 12x minus 5. And guess what? They cancel each other out. And then over here, the x's cancel each other out, and then 6 divided by negative 2, your answer is negative 3. I hope this was helpful.